it's found to be life, and know the joy within you dies. Don't you want somebody to love? Don't you need somebody to love? Wouldn't you love somebody to love? You better find somebody to love. Don't you want somebody to love? Don't you need somebody to love? Wouldn't you love somebody to love? You better find somebody to love. Don't you want somebody to love? Don't you need somebody to love? Wouldn't you love somebody to love? You better find somebody to love. Don't you want somebody to love? Don't you want somebody to love? Don't you want somebody to love?
I walk a lonely road, the only one that I have ever known. Don't know where it goes, but it's home to me, and I walk alone. I walk this empty street on the boulevard of broken dreams, where the city sleeps and I'm the only one, and I walk alone. I walk alone, I walk alone. I walk alone, I walk up. My shadow's only one that walks beside me. My shallow heart's the only thing that's beating. Sometimes I wish someone out there will find me. Till then I walk alone. I'm walking down the line that divides me somewhere in my mind, on the borderline of the edge and where I walk alone. Read between the lines what's fucked up and everything's alright. Check my vital signs to know I'm still alive, and I walk alone. I walk alone, I walk alone. I walk alone, I walk up. My shadow's only one that walks beside me. My shallow heart's the only thing that's beating.
What is web development? Web development is the ability to create a website for your laptop, tablet, or a phone. So typically we create one website that looks and acts well on all of these devices in the exact same code base. And this is called responsive web design. So whenever you hear the term responsive web design, it really just means the website looks good on a desktop, on a laptop, on a TV, on a phone, things like that. Now we write code, typically in English, but not always, that tells programs what to do. And there's a certain way to write code, and it's a little bit different for each programming language. And those differences, those little style tweaks, like if we use curly braces or semicolons, things like that, that's called programming syntax. And so it's really just the how do we write it. It's like writing apostrophes in English, apostrophes, periods, question marks, things like that. That's sort of English syntax. And in programming, we have sort of the same thing, but it's not quite the same as like writing a paragraph. Now, websites are made up of 4 main components. The first one is HTML. This is your bone structure of your web page. Every single site uses HTML. CSS, that's cascading style sheets. That's the part that makes your website look beautiful and full of color and have nice images and things like that. And then there's JavaScript, and this is the third component. And JavaScript is the interactivity that happens when you click a button or you type in a box and something else happens. Some sort of event happens. So whenever you click on something or you type somewhere and you can see things moving around, that's JavaScript. Lastly, we have a server-side component, and this is the hidden code that executes on a server when your browser loads a website. For example, you could use Python or PHP or Node.js. How to get into web development. So I get a lot of questions all the time just because I teach so many people, but I also get these questions very often. These are probably the most common questions I get. First of all, is it hard to get into web development? Do I need to be super smart to start coding? Am I too old to learn how to code? Do I need a college or university degree? And is it expensive? So let's go through each of these one by one. Is it hard to get into web development? And the honest answer here is no. It's not hard. It's a lot like learning how to cook. You learn 1,000 small things, but not one giant thing. Now, it will take time to learn, but it's not going to be hard to learn. And you don't have to memorize the 1,000 small things either. You just have to remember how to find those answers on the internet. Do I need to be super smart to start coding? Honestly, no. Any normal person can do it, and that's what makes it so appealing to everybody. People think coders are as smart as Bill Gates or Mark Zuckerberg, and honestly, that's just not true. We're not that smart. We just know how to use our tools really, really well, and we know how to find answers on the internet. So all we do is hop on Google when we get stuck and look for something, and someone else has probably ran into a similar solution or a similar problem and found a solution and posted on the internet. So we can leverage other people's experience there. Now, the brutal and honest truth about this profession, my profession, and hopefully one day your profession, is that honestly, you don't need to be very smart and you don't really need to memorize too much. You just need to know how to find the answers. Am I too old to learn how to code? I get this one a lot, and this one actually drives me insane. Okay, so I've seen students in their 70s learn how to code, and they've been doing it very well for several years now. I've seen people in their 60s learn how to code and get a job in web development agencies and succeed. They're doing very well. So in summary here, you do not need to be young to learn how to code. That is a myth. Next, do I need a college or university degree? No, that is not necessary. So even though college or university might be helpful to understand how computers work and how to get into computer science and some of the mathematics for like machine learning and stuff, when you're making a website, you don't need to know any of that stuff. And a good example is me. I taught myself how to code at the age of 10 in about 1999. No college would have taken a 10-year-old. And today I've still not attended college or university, and I've worked with big names like Mozilla, NYPR, the National Health Service, and NASA. So just think about that. You do not need a college or university degree. Lastly, is coding expensive? Now, coding is only as expensive as you make it. If you like the finest tools, if you like to pay for things, it's going to be expensive. But the truth is, most of our tools are 100% free. Web development education can be expensive if you attend a boot camp or if you pay for a mentor. But your best route is to take the inexpensive route. So take online courses such as this one, read blog posts, and read tutorial websites. And if you have a laptop or a desktop already, really it shouldn't cost you more than about $100 to get into this. So what do you need to get started? Well, you do need a laptop or a desktop. No, you cannot efficiently code on a phone. I'm going to tell you that right now. A lot of people say or ask, hey, Caleb, can I code on my phone? And the answer technically is yes, but it's going to be very painful, very slow. It's not efficient. You won't be able to learn as much as you possibly can. So you need a laptop or you need a desktop. You need something with a full keyboard on it. Next, you need a text editing program. I'll talk more about that a little bit later, but these are always free. And lastly, you need internet access, and chances are you're watching this online, you're probably streaming this, so you likely have good enough internet to get started. What does it take to get into web development? First of all, it takes determination. Learning to code is not hard, but it's big. And I've said this before, and I'm going to say this again. You're going to be learning about 1,000 small steps. And most of these you can Google. You don't actually need to remember all of them. But taking 1,000 small steps, again, it's not hard. It's just big. You'll need to learn how to deal with overwhelm. There is a lot to learn. And again, it's all small stuff, but it can feel very overwhelming just because there's so much of it. So don't try to learn all of it at once. Learn how to code in steps. Take baby steps. I suggest learning HTML first, and we'll get into this a little bit later as well. Support groups are your best friend. You do not need a personal mentor to start. Although if you have a friend who's willing to teach you how to code, that's fantastic. But honestly, you don't need that. Find a support group where you can ask questions without being judged. I recommend the Learning to Code Facebook group. It's free. It has over 55,000 members who can answer pretty much every web development question that comes to mind. And you can ask any question at all. All right, it's also going to take tenacity. You will have hard days. That's normal. It still happens to me, and I've been doing this for over 2 decades now. But you need to push through those hard days. Now, to do that, I suggest building a habit where you learn just 3 new things about web development every day. Even if they're small, useless facts, you're still building up that habit, that sort of ability to continue learning every single day, even when you don't feel like it. That's really, really important. Lastly, practice until it hurts. Practice, practice, practice. Like anything in life, coding is a skill that gets easier with practice. And once you have enough practice from tutorials and courses and other things, make sure you start working on your own ideas. Because if you solve real-world problems, chances are you have an idea that's tackling some sort of real-world problem. You'll run into real-world coding problems and their solutions. And that's valuable. That's what's going to get you a job in the future, is being able to tackle those kinds of problems and find solutions for real-life problems. Web development tools. First up, we need a text editor. A text editor is really just a special program that doesn't add hidden data to your files. So if you ever used Microsoft Word and you can put tables and stuff in there and you can embed images and stuff, we don't want any of that. That has extra hidden data behind the scenes. We don't want that. Now, I highly recommend downloading and installing VS Code. It's free, it's popular, it's very powerful, and again, it's free. And you can use it on Mac, Windows, Linux, pretty much every operating system out there. Next, you need browsers. Different browsers render content differently. So if you can right now, I would highly suggest just pausing this video and going and installing Google Chrome. Download and install Mozilla Firefox. If you're on a Mac, download Safari. You probably already have it if you're on a Mac. Unfortunately, I don't believe it's available for Windows users, at least not at this point in time. And lastly, get Microsoft Edge. You want these 4 main browsers to test your websites on. Next up, you need a command line program. Now, luckily, every computer has a command line program built in by default. On Windows, your command line tool is called CMD, command. On Mac, your command line tool is called terminal. And on Linux, your command line tool is called bash. Lastly, you do need one more thing to efficiently learn how to code. You need internet access. All of humanity's knowledge is at your fingertips as long as you have internet access. So for that reason, it's important to have internet. We do a lot of searching for answers on the internet as well as web developers. We don't know all the answers. We don't memorize the solution to everything. We try to figure it out, and sometimes we forget things. I even forget basic things sometimes. You just hop on Google and ask your question in Google or in a Facebook group. How websites are created. Okay, first of all, there's two sort of things we need to know. I guess we don't really need to know right now, but let's cover it anyways. There's scripting and programming languages. So a scripting language is like throwing instructions into some sort of machine, and it just sort of does what you want it to do. And that's very similar to a programming language. But a scripting language is kind of like putting popcorn into a popcorn making machine, and it just like pops your popcorn for you. Whereas a programming language is like being able to program the popcorn machine. Now, we write all of our code in a text editor that satisfies the program's ability to read your code. And that program is your browser. So if we said, right in here, less than b greater than hello world, less than / b greater than in HTML, it would look like this. It would be bold. This right here, this b and this b, tells it to be bold. These are instructions for what your browser needs to do. Next up, you need a text editor. And again, you want one that doesn't add hidden data to your file. So don't use Microsoft Word or anything like that. I highly recommend downloading and installing VS Code. Again, it's free, popular, and very powerful. So if you haven't, I would really like if you could just pause the video here, go download and install VS Code, because we're going to need it at the end of this course. Websites are created when we write code. So writing code is a lot like writing a paragraph. It just looks a little bit different, and we call this syntax. So you can still read the code, and it's like reading a different language, but your brain still understands what's going on. We follow rules that programs like a browser are looking for. For example, if we said b hello world /b or I hello world /I, that's going to output hello world in bold or hello world in italics. What you see and interact with on a website is really only made up of 3 components: HTML, CSS, and JavaScript. HTML and CSS are considered scripting languages, and JavaScript is an actual programming language. And there are some differences, but honestly, it doesn't really matter what those differences are right now. We can get into that at some point in the future. But pretty much every website uses these 3 technologies today. HTML files are saved with a .html file extension, CSS files are saved with a .css file extension, and JavaScript files are saved with a .js file extension. And for the most part, that's the biggest difference when it comes to just managing our files. It's just the file extension. As soon as a browser sees that there's a .js or .html file, for the most part, it can figure out what to do next. And we write all of this in a text editor, and we just use different file extensions. Let's look at programming languages. When you hit a website, a server is sending you that HTML, CSS, and JavaScript. But the code that executes on the server can be a completely different coding language. It can be Python, PHP, Node.js, Java, C, etc., etc. It could be really any language, and you're not going to know what that language is. But we also write that code in a text editor. And again, the text editor could be VS Code. Now, one more component that we're not really going to touch on too much in this course is databases. So when you try to log into your website, or any website, your data is sent to the server. So that's the code that you cannot see. We call that backend code. And it talks to a hidden database. And that database is supposed to be hidden to keep your data nice and secure. These databases are what store your passwords, your usernames, your email addresses, which photos you uploaded, which posts you liked, so on and so on. Basically, anytime it remembers that you did something at some point, that's being saved in a database. And a database is really just like the memory of a website. Code you can't see. All HTML, CSS, and JavaScript can be seen by your end users. So never store secrets in there. If you right-click on pretty much any web page and click View Source, or go to, I think it's usually File View Source, you can actually see the raw HTML, CSS styling, and the JavaScript. That's all considered front-end code. And again, back-end code is what runs on your server, and you cannot see it. We don't have access to that. But front-end code is completely accessible to your users. So again, do not put passwords or anything like that in there. No sensitive data, really. Front-end versus back-end coding. So I touched on this in the last video, but front-end coding is made up purely of HTML, CSS, and JavaScript. These small files are sent to your browser, and your browser then reads them, interprets them, and then displays them for you. And if you right-click on any page and select View Source or Inspect, you can actually see the entire front-end code. It's completely available to you. Next up, we have backend code. Backend code is a programming language like Python, PHP, Node.js, Java, something like that. It usually produces some sort of HTML to send to your browser, but the logic behind the scenes is never actually exposed. Whereas with front-end code, that logic can be completely exposed. You honestly don't really need to know too much of the difference right now, because when you get started, the first thing you should learn is just HTML. So you don't have to worry about learning all of it. Just start at the beginning with HTML. Now, backend code is really useful for securely handling passwords, credit card numbers, and other sensitive data, things that you don't want to be present for anyone in the world to see. And backend code usually connects to a database where your data is saved for a period of time. This lets you log into a website like Facebook after, let's say, 6 months. Your login information was saved in a database. That data was processed using a backend programming language, and then all of a sudden you're logged in. There's a little bit more to it, but again, you don't have to be too concerned with that right now. Full stack web development. Full stack web development is front end plus back end plus a database. That's all that means. A full stack web developer can write front end code and back end code. So this usually means they write a lot of JavaScript along with a back-end language such as Python. So in this example, Python executes on the server and JavaScript executes on the browser. And every time you hit a website, there is a server doing some sort of processing, somehow behind the scenes. Now, one thing to note is a back-end language can dynamically create HTML, CSS, and JavaScript as well. Let's talk about the stack. A stack is a term we use to talk about all the technologies that a company is using, and stacks can be different. So two popular stacks is LAMP and MERN. LAMP is a common stack. It's Linux, Apache, MySQL for the database, and PHP or Python for the back end. And MERN is another common one. This one is pretty much all JavaScript. It's MongoDB, Mongo database, Express, React.js, and Node.js as the backend language. A full-stack web developer is usually one who writes front-end and backend code, but often doesn't have specialization in all areas. But they can do a little bit of everything. So typically a full stack developer specializes in one or two languages, but can still work on other languages. For example, I specialize in writing Python, but I can also write JavaScript as well. Working with teams. Now this is absolutely vital. Web developers work with many other web developers these days. That's completely normal. So if you're trying to get into web development to avoid working with people, unfortunately, that's just not a reality anymore. That was normal 20 years ago, but not today. So being able to write code that you and your team can access and work on together is absolutely vital. In order to break into web development, you're going to need to know how to work with other people, and they're going to need to know how to work with you as well. Now, we use a program called Git. Git is a version control and collaboration tool that developers use to basically share their code and go back in time in case they made a mistake. Now, we tend to dump our code into a Git-based service like github.com, where other developers can download the code and make updates. GitHub.com and GitLab.com are the two leading Git websites right now, but there's also other ones out there like Bitbucket, but they're not as popular anymore. Now, once again, and I cannot stress this enough, but Git is a vital part of web development. Its importance is often undervalued, but I can promise you right now, you'll be using it with every single team that you work with in the future. And just to reiterate, the reason why it's so important is because you could write some code, and then I could write some code, and we could share it. We could merge it together. We could make one code base out of two different pieces of code on two different computers. So how it works is actually pretty simple. You can, let's say, code for like an hour, and you can save your progress in this thing called a commit, and then you can save it on github.com. Now, if tomorrow you realize you made a really bad mistake and you want to go back to whatever you did today, you could do that with Git. Or if you accidentally deleted all your code on your computer, you would have a permanent backup. Now, this is called distributed software. And the nice thing about that is other people can pick up where you left off. So if you're working across different time zones, You can work on a particular feature, and a little bit later during the day, someone else can pick up exactly where you left off. Let's talk about open source. So what is open source? Open source code is code that people have written that they're literally giving away for free, or at a bare minimum, they let you see what the source code is, and they maybe have some sort of license that you can use their code as well, but you can still see the code. So a good example is with like backend code on a website. You cannot see what the developers have written, but if the code is on github.com and it can be stored in this thing called a repo, which is short for repository of code, then you can see what they're up to. You can see all the code. You can see if there's any sort of security vulnerabilities. You can see what they're doing with your data. Now, open source is incredibly, incredibly important. Most employers like seeing that you can actually use Git and GitHub. And because most open source code is available on GitHub, that's kind of important. But you'll also get bonus points for open source contributions, meaning you wrote some code that went into someone else's open source project. And that's just called a contribution. And that shows future employers that you're able to work with other people, that you're able to follow other people's rules, because maybe they have certain rules for their source code, and that you're able to use Git and GitHub. Lastly, open source is everywhere. So believe it or not, most interactions you've had on the internet are likely because of open source code. The internet's a free and open place where you can create and share pretty much anything with anybody. And web developers are the people who are often responsible for making that sharing possible. Do not reinvent the wheel. If you want to add a big feature to your future website, look for open solutions first, open source solutions. There's no reason you need to duplicate the effort that someone has already put in. Honestly, use other people's work if it fits your needs. That's why they open source their project really in the first place, is so that other people can leverage what they've worked on. So let's take a look at an example here. I'm going to close this down in just a moment and open up my browser. We're going to take a look at slick.js. It's a common JavaScript library for creating amazing carousels of images. So let's see why this is important to leverage existing open source work. So this is just my browser, and I'm going to type into Google slick.js. And this is the first one we want here. The last carousel you will ever need. Now this is what a carousel is, right? These could be different images. You could move multiple images at once, responsive display, variable width. So if your images are different sizes, it will adjust automatically. It has adaptive height, has captions and stuff in there. You can actually see my arrow is moving so it stays centered. There's center mode, which is pretty nice. But if you needed to add this to a website, you could write this on your own, and that would be somewhat of a nightmare because these are not super easy to create. But if we go up to Get It Now, it says view it on GitHub. Okay, let's view this on GitHub. So I'm just on github.com here, and I'm zoomed in, that's why it looks so big. And I click on Slick, and if I go to slick.js, I can see all the source code. So there's 88 kilobytes of data in the source code, 3,037 lines. Now, if we just keep scrolling, we can see that there's like a lot of logic, a lot of different things going on in here. But if we scroll all the way to the bottom, you can see there's 3,037 lines of code. And if you use this person's code, you do not have to write 3,000 lines of code. You don't have to put the effort in to figure out all the edge cases. Does it work on all the different browsers? Does it look great? Is it responsive? Do all the features work across every browser? Things like that. We know that this is tried and tested. We don't have to worry about this not working. So I'm just gonna scroll back up to the top here. Go back over to, look at this. 26,100 people have started this, and there are over 5,000 forks. So 5,400 people have basically copied this code base into their GitHub account so that they can modify it. But again, the big power in open source is being able to leverage other people's code. Okay, let's get started writing some code. So in order to get started, we need to download a text editor such as VS Code. You're going to need that. You're going to need to download Google Chrome, Mozilla Firefox, Apple Safari, or Microsoft Edge web browsers. Try to get all four if you can, but if you're on Windows, you probably cannot get Safari. Then here's what I want you to do, and I'm going to demonstrate this in just a moment. I want you to open your text editor and create a new .html file. And then if you want to dive in from here and really get into all sorts of coding stuff, I highly suggest learning HTML first. It's easy, should only take you about 3 days to really understand how HTML works, and then you can play with CSS to make your website look beautiful. I've also got courses on both of these subjects. Do a search for Caleb Tallien and you'll see them in my profile. So I'm going to open up my VS Code. And let's just make this a wee bit bigger here. So if you open up VS Code and you don't have this, you'll probably see something along these lines. It might look a little different colors because I have a specialized theme in here. But you can always go to File, New File. That's just out of my recording area, but it's right at the very top there. And it's going to create just an untitled document. And I'm going to zoom in. Now I'm just going to go to File and Save. And I'm going to save this to my desktop. I'm going to call this Hello World.html. Now in here, all you have to do is type something like this. H1 Hello World/H1. Now this is HTML, and this is HTML, and this is just called plain text. So let's go ahead and save that file again. And let's go back to Firefox, because that's the browser I was using. And let's go to, let's open a new tab. I might not need to open a new tab here. If we go to File, and then we can open a file. And if I go to my desktop, we can see there's hello world.html. Let's go ahead and open that. And it says hello world in big letters. Now, comparatively, that's going to be hard to tell that they're big letters. So let's create a paragraph. Paragraph in here, /p. Again, I just saved that. And if I refresh this page, paragraph in here, and hello world is in big text. And I'll zoom in again, and you can see the difference here. If you do that, you've effectively created your first web page. So go ahead and give that a shot. Remember, you need that .html file extension. It can be called really anything. It didn't have to be hello_world. It could be anything you want. Just write something like this. You can even just literally copy exactly what I have written here, save it into a .html file, open up your browser, and then go to File, Open, and it will show your website for you. All right, first things first, let's take a look at what a browser is. So what is a browser? A browser is a program that asks a website for information. This ask is called a request. And when the request is completed, the website returns an answer called a response. It's a lot like when you pick up the phone and you call your mom or your dad or your best friend. They pick up their end of the phone, they say, hello, that's the response. Now, the response has data in the form of HTML, CSS, and JavaScript. It can also include things like images and other forms of data, but we're not really going to touch too much into what that is. But really, you just need to know that the response has this thing called a payload, and it sends back files. And then your computer downloads all of these little tiny files, and your browser is the program that reads them, pieces them all together, and makes your beautiful website. Now, when it pieces things together, that's called rendering. So it's going to try to render the final output. Now, there are 4 major browsers. There's actually thousands and thousands of browsers out there, but there's 4 major ones: Google Chrome, Mozilla Firefox, Apple Safari, and Microsoft Edge. But again, there's hundreds, if not thousands, of smaller, lesser-known web browsers available. Your phone might even come with a different one that's not one of these 4. What does your browser do? So your browser collects information, and its job is to display it. Now, when it collects information, it's actually just asking a server, hey, can I have some information? The server says, yep, you can have this information, sends the files. Your computer then downloads them, or your browser will download them, piece them all together in a nice way, and kickstart all the code. And that sort of creates your nice interactive website. Not all browsers are the same. That should actually say not now. Not all browsers are the same. So what works on one browser may not necessarily work on another browser. So if you ever stumble on a website that seems broken in, let's say, Google Chrome, try opening it in Firefox, or vice versa, or Apple Safari, or Microsoft Edge. Just try it in another browser, because sometimes the rendering engines behind the scenes don't work the exact same. They're supposed to, but they don't always. Your browser's job is also to communicate. It's responsible for the communication/transactions between your computer and the website. And again, it's like picking up the phone and dialing your best friend. You need to wait for them to actually answer the phone, say hello, and then you can start a conversation. What are web requests? A request is simply asking for information. So web requests are when you ask for information from a website. You're simply asking for the files that you need to display the website. And often this is called a handshake. So let's take a look at how this works. It starts off by going to a website like google.com. Your browser then asks google.com for the data it needs to display the page nicely. Now, this whole process is called a request, and actually when it sends you the information back, it's called a response, but we'll touch on that in just a little bit. Requests can have sizes as well. So a request can be literally any size. Google.com is a small request, or really any website. We're just going to the website and saying, hey, can we have the files? And then the website determines what it should send back. But that first request, that first handshake is usually pretty small. Now, if you load up something like Instagram.com, every image will be a new request. So as you scroll through your Insta feed, it's going to load more and more images, and that's going to be a new request every single time. Or if you go on Facebook.com, every comment you make, every like that you click, those are all requests. It's a different type of request. And again, we'll get into that in just a little bit, but all of those are called requests. Anytime you send a little piece of data to a website to either ask for information, or even to ask to delete information, or update information, or to save information, those are all requests. And these are called request types. So sometimes a request comes in the form of asking for information. And this is called a GET request. But it can also be in the form of asking to save information. Now, technically, those are called POST requests. There's also a delete request to delete information, and a put or patch request to update information. And once again, a normal handshake is just a GET request. That's the most common one. And this is actually getting into RESTful APIs. Now, if you're interested in APIs, I have a course on RESTful APIs. Feel free to go and take a look at that after this course. Now, one thing to note is that everything has to travel through the internet. Smaller requests and responses means less bandwidth. It means it can travel through the internet, through the wires that are sent all across the globe, through your Wi-Fi. It can serve that a lot faster because it's a lot smaller. It's a lot like this. Think about the last time you had to download a 1 gigabyte file versus downloading a 1 kilobyte file, right? The 1 gigabyte file takes a little while. It could take several hours depending on your internet speed, but a 1 kilobyte file, even if you have fairly slow internet, is still a very, very fast download. Requests are the exact same thing. The request lifecycle. So let's take a look at how this begins. When you ask for information from a website, you're actually doing a lot more than that. When you ask, let's say my website, caleb.io, for information, there's a domain mapping behind it. So caleb.io actually points to an IP address, and that IP address connects to my server. So you're not actually requesting information directly from caleb.io. It's just sort of masking it so that you don't have to remember IP addresses. And then how it ends. The server is going to accept my request or your request. It's going to understand what it's supposed to output and sends files like HTML, CSS, JavaScript, images, all that other stuff that makes your website look good in this thing called a response. Lastly, the browser downloads these files and saves them onto your computer. And if it has to download it more than once, sometimes it'll just use the old files, and that's called a cache. It's going to then piece all these files together and render your content. What are server responses anyway? So a response happens when a server responds to your web request. A response happens after the request is made, so it always goes request and then response. And responses can be pretty much any format, but typically it's HTML, CSS, JavaScript, or plain text or JSON for like an API. If you don't know what an API is, honestly, that's okay. You can just ignore that bit. But if you're interested in learning a little bit more about APIs, there are some cases where an API, also known as an application programming interface, will send XML or JSON formatted data. Now, typically it's kind of like plain text. It's not really specialized markdown too much. It has some rules, but not too many rules. But the nice thing about that is because it's sort of plain texty, that means there's not much to interpret, and your browser can deal with this a lot faster. Or your server even could deal with this a lot faster and then render HTML, CSS, JavaScript, whatever it needs to do. Now, often, JavaScript or a server programming language like Python is going to handle these API responses. Again, if you don't know too much about APIs, if you're brand new to web development, don't worry about this part right now. So as an example, when you load up Instagram.com, you're making a request to the website to load the initial data. As you scroll down, it loads more and more images dynamically, so that the first request can always be small and fast. It really only shows you or tries to get like 2 or 3 images, but it's not going to save 1,000 images, or it's not going to ask for 1,000 images because that's going to be really slow to load. Your request is going to be a pretty small request payload, and that response is also going to be a fairly small response payload. And that just means that, for example, Instagram.com can load really, really fast. Now, as you scroll down the page, you're going to see that more images show up, and sometimes it's so fast you don't even notice. That second request, third request, fourth request, when you click load more on any website or you scroll down on Instagram, is usually an API endpoint that returns JSON or XML. And the reason is because both of them are a lot more lightweight than HTML. Then your browser reads the JSON response, for example. JavaScript takes over and it says, oh, I need to display more photos. And it dynamically creates your HTML structure for you and adds it to the page. And as soon as it's added to the page, your browser then takes over for JavaScript and says, oh, I need to make another request. And then the cycle repeats. The server says, oh, there's a request coming in for this particular image, serve that image. Now, on the topic of images and other assets like images, each one is likely to be its own request. So the browser creates a new request for each image file to download. The server sends a request with the image data, and again, your browser then displays that image. Though technically there are ways to bundle responses together for a faster one-time payload response. This way you can just ask the server once and it will send all the images all at the same time, so it doesn't have to go one by one. And again, that just makes that response payload faster. And the reason for that is because if you think about driving to and from work or to and from the hospital or to and from your house, there's a lot of travel time in the internet. And so if you can reduce the travel time and just carry all the images in one load, then it's going to be a lot faster. Interpreting HTML, CSS, and JavaScript. So these are the most common response data types. So when you make a request and you get a response from a server, you're likely going to be getting HTML, CSS, and JavaScript. Your browser's job is to download each one of those files. But the browser also has these things called engines. And so these engines have certain rules for HTML. They have different rules for CSS, and they have different rules for JavaScript. If your browser thinks it's opening a JavaScript file, it'll use the JavaScript engine to read and interpret and make your website interactive. Likewise with CSS and HTML. So if it realizes that there's a CSS file, a cascading style sheet file that is, it's going to try to interpret that and make your website look good. And so they have different purposes. Once all the files are downloaded, as best as they possibly can, it's going to piece them all together, and again, it's going to try to display your website, or it's going to perform a render. But at some point, JavaScript is going to take over the browser, just because the browser has a particular purpose, but JavaScript also has its own purpose. So after the initial response is rendered or displayed in your browser, most of the time, JavaScript is going to take over. Not all the time, and sometimes there's some cooperation between JavaScript and your browser. JavaScript can tell the browser to make more requests on the fly by dynamically adding links, images, and other assets to your page, or by directly communicating with the browser and creating a new request. So JavaScript can make its own requests, but your browser can also make requests too. Viewing your request. And responses. So to view any sort of request and response, you're going to need a modern browser. I recommend Chrome or Firefox for this. And then I'm going to demonstrate in just a second how I can see all the responses from a website like google.com. So you're going to want to pay close attention because you'll be trying this in the next video. So I'm just going to get out of this and go over to google.com. And so this is just the regular Google website. And what I can do is right click, go to inspect. And you're going to see these options in here. Now yours might be a light color mode. So I've got dark mode on, and this might actually show up on the right side or the left side, but either way, you're going to see sort of these options here. For us, we're going to want to go over to the network tab, and we're not going to see anything in here. And I have mine filtered by CSS already. Let's go ahead and filter that by all. And if you don't see anything, that's totally fine. This is going to process all the requests that are coming in right now from the time you open this to any time you close it. So let's go ahead and just click refresh, and we can see all these requests were coming in. And so there's a lot of different things in here. We have a document, which is HTML. We've got a PNG, that's an image. WebP, that's also an image. We have a plain text one in here. We've got a text HTML. We've got a script in here as well. We've got all sorts of stuff that we can see. And maybe what I'll do is I'll just make this a touch bigger. So if we wanted to see an image, we could right click and then go to open in new tab. And that's the image that it loaded. So we now know that Google made a request for its own logo. Let's take a look at another one here. Right click, open in a new tab. And this is what's called a sprite. So it's one big image with all these little symbols in it. And then it uses CSS to sort of display the images, like just a particular part of it. So like just the notification sign. Now the benefit to doing this is it's making one request for the image instead of making 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I don't know, 20, 25 requests for all these different images. It just has to do the one. And so that's significantly faster. And that's how Google loads so fast, is it really optimizes these request response life cycles. Now you can also filter by JavaScript. So let's see what happens when I type in here, KALOB. And you can see in here that it's doing a search for Q is equal to K, Q is equal to KA, Q is equal to KAL. And as it types, it makes a new request every single time. Now this is all JavaScript. This is not your browser. This is JavaScript doing this. And this is using a thing called AJAX, or the Fetch JavaScript API. If you don't know what those are, that's honestly okay. We can look at just JavaScript requests. So these are the files that we requested from JavaScript. We didn't request any CSS at the moment. I don't know why that doesn't seem right. I guess there's no CSS in there. That probably means if we go into here, right click and view page source, we're going to see all the CSS in here. And there it is. All the CSS is in the page. So it wasn't loading any CSS files. It came with the HTML document. Interesting. We can also see all the different images, medias, fonts, documents, WebSockets, manifests, all these other things. Now we can also see, if I just go back to all, how long it took to get, what the file size is. We can filter by the file size here. We can see the biggest file here was the document itself. That's the entire page. It was about 61 kilobytes and it took 140 milliseconds to get. And again, the idea here is that I went to google.com. Google.com is going to point to some form of IP address that's going to connect to some server that they have. That server is then going to say, oh, okay, well, serve this HTML document and serve all these other assets with it as well. And so essentially, I asked for a bunch of information. I didn't even know I was going to be asking for all of this, but I asked for a bunch of information from Google. Google determined what information it needed to give me, and then as a response said, here, have all of these files in here. And that effectively is how you view your requests and your responses. Again, you don't need to use Google Chrome. I was just using Chrome because that's the tool that I like to use when I'm doing things like this. But you can also use Firefox, Safari, Edge. Really, any browser will be able to do this. Your project. So here's what I would like you to do. I want you to open your favorite browser. Could be Chrome, Firefox, Safari, Edge. Load up my website, just as an example. Go to caleb.io, right-click on the page, and then inspect, and then click the network tab, and then refresh your page if you don't see anything like we did in the last video. And then I want you to be able to filter your responses by documents, so like HTML, CSS, images, or JavaScript, and just kind of see what kind of things my website's going to try to serve you. Find an image and then open that image in a new tab, and then take a screenshot of your network panel. Just the entire panel, not the image itself, but take a screenshot of your network panel while it's open with all the different requests and responses in there, and share it in your project section. Now don't worry, anything you're doing here, it's not going to break your browser, it's not going to hurt your computer, it's not going to do anything that you can't undo by simply clicking the refresh button on your browser. So feel free to experiment, it's completely safe to do this. Go ahead, give us a shot, take a screenshot of your network panel while it's open, share it in your project section. And once you're done that, you have completed this course. Thank you for taking the time to watch this course. I hope you learned something new and exciting. Again, this is really important when it comes to web development. And if you wanted to learn more about HTML, CSS, JavaScript, APIs, anything like that, always feel free to view my profile. I have courses on all of these subjects already. Thanks again, and I hope to see you in another course.